Great. I'm going to talk a little bit about the construction industry. So, first of all, the construction industry is a big industry. It's $7 trillion annually. It's about 10%. It's about 10% of GDP. So this is something that affects every country in the world and affects just about everybody in the world. The thing that's interesting about construction is that I think it's perceived right now that it's going through a point of inflection. In other words, technology is finally starting to change how we build things. And you can talk about other industries, how slow they've been, but I would say that construction has probably been one of the slowest. A lot of the tools and things we use today haven't changed that much from the Romans. And so what I like to do is just touch briefly on some of the technology, and I'm sure you've heard of it. You've heard of this technology. This won't be the first time. But I think what's really happening is that this technology is converging, it's coming together, and it is transforming how we build things. And I'll give you a couple of examples. You've probably heard of building information modeling. What this means fundamentally is that instead of using a CAD tool to produce a piece of paper, like Blueprint or whatever, we're now using other tools that actually create an electronic model. These are 3D, but the most important thing about them is not that they're 3D. The most important thing about them is that they've got intelligence. And you can do interesting things with building information models. You can do clash detection. In other words, detect where the electrical system is going to clash with the plumbing or with the elevators or with the fire control system and so on and so forth. So this is a huge thing. This is changing not only how people design things, but it's changing how construction companies build things. They now can model the construction process itself because they have this kind of information. The other thing is something close to everybody's heart in this room, and that is geospatial. Laser scanning is transforming how people collect information about existing structures, how they monitor construction progress, how they compare what is actually built to what's being designed. Laser scanning can do that to millimeter accuracy. And another area, which actually came out of the gaming industry, is that you can now use those kinds of geospatial plus building information modeling with gaming technology to actually simulate what something is going to look like when it's built, before you actually put a shovel in the ground. This particular example is a Parsons-Brinckerhoff simulation which allowed you to drive a highway before it was built. This is a highway, this is a Presidio Highway in San Francisco, which still hasn't been built. But you can do this for buildings, for highways, for railways, and so on. When you take all these things and bring them together, this is what I've been calling convergence. It breaks down silos. It allows you to use a number of different technologies to solve problems in ways that have not been possible in the past. And it really means now, at this period of time, that we're changing how we build things after 2,000 years. It allows you to actually build models of entire cities, and I'm going to give you some examples. This is not Star Wars stuff. People are doing this right now. So I'll give you some examples of what people have done already, and then I'll touch on some of the legal and policy issues that arise from this. And so what we're talking about here is underground infrastructure, above ground infrastructure, inside buildings, outside buildings. Just to give you a real good use case for this, you may know, if you've been in the construction industry at all, that before you dig a hole in the ground, you call up the one-call center, and usually 7 trucks converge on your site. The reason 7 trucks converge, some of them are from the water utility, some of them from the city, some of them from the electric power, some from telecom, is because they don't know where their stuff is. Okay? They come with magic wands, and they detect where those things are. And these gives you some idea of the statistics, but the number of things that get hit and hold up projects and ruin schedules and budgets is phenomenal. And this is one of these things that has been going on for a long time, but nobody has really addressed. And I'm going to talk about one city that has tried to do something about this. Las Vegas, of all places. About 4 or 5 years ago, got interested in this because they realized how much it was costing them every time they hit underground facilities, when they dug up the road, dug up something for a new casino, and whatever. And they actually put together a database of in 3D. Most of the time when you see underground facilities, it's 2D. You don't know how deep it is. There's often construction standards that give you some idea of what it should be. But in this case, they did it in 3D. They've used various things like ground-penetrating radar, other technologies. Above ground is usually it's laser scanning. But they put together a 3D model of the underground facilities. And these are some examples of this, just showing you what it looks like. And this is an example of an augmented reality app running on an iPad that means you can look at a street and you can see what is actually underground. Los Angeles Community College has done the same thing. It's a little bit easier because this is a college, they own everything. When you do it in LA, you've got a problem because you have to deal with 5 or 6 companies, including telecom, utilities, and so on. In this case, students actually built BIM models of this is the largest community college in the United States. There's 9 campuses, 250,000 students. The students actually built the BIM models for this campus. And these give you some example. You can see it's inside, it's outside, it's underground as well. And interestingly, it's actually used for simulations for security training. This is a very interesting one. This is Sydney Down Under in Australia. This not only includes underground facilities and above ground facilities, but all buildings above ground and underground, and it's linked to the land ownership database. So if you want to know who's on the 5th floor of this building and you have and you need a telephone number to call them up because of some problem, you can do it. This was done for emergency planning purposes. 200 organizations collaborated to provide the data to do Sydney Down Under. This is Belo Horizonte, Brazil. This is a university project, but the city of Belo Horizonte is very interested in this, as is the Federal Ministry of Urban Affairs, or cities, is also interested in this. And in Brazil, if they do get interested in this, it means probably all the cities will start doing this kind of thing. This is another example in LA. So what are some of the policy issues? One of the things that's happening as a conjunction of the convergence of geospatial and engineering data and 3D visualization is that the construction process is changing. Currently, what happens is surveyors come in, every time you do a construction project, they start as if this is pristine ground. The surveyors come in, survey the area, create what's called a base map, and you do all your design and whatever from that. And the result afterwards is as-builts. The interesting thing about these as-builts is that nobody's reputation is on the line, nobody's professional accreditation is dependent on these things. These things are useless, nobody pays any attention to them. Okay? The new process is going to change that. First of all, those as-builts are going to be verified by a post-construction survey. There's going to be a permanent database, geospatially enabled, of all this data so that when you start a project, you start at 80 or 90% of what you need without having to do a resurvey. This is a dramatic change. What I'm showing you comes from the Oregon DOT. This is not a university project. This is something that is going to happen. The issue here is who's liable. When you have surveyors out there going over the ground and determining where things are and where underground facilities are, for example, then if you've hit something, you can sue somebody, to put it bluntly. And in this model, things are going to change. Who you sue is going to change. And this is going to have dramatic implications for policy, for legal issues relating to construction, which, as you know, is a huge industry. This is another thing that affects this, and this affected Las Vegas, and that is there's something called the Protected Critical Infrastructure Information Program, which has to do with Department of Homeland Security, which puts restrictions on what you can do with underground facilities and above-ground facilities. And Las Vegas had to jump through hoops to get around this so that they could actually put together a database of all their underground facilities. This is another example. This is actually from Toronto, but this is a Freedom of Information Act. It looks very nice. It says, well, for example, as part of permitting, if I submit some floor plans to City Hall in Toronto, I can go down. Anybody in the public can go down there and look at those things. But there's a little bit of a catch on this thing, and these are some what are called mandatory exemptions of when I don't have to make that available to the public. One of which is if I'm divulging competitive information. And often engineers and architects worry about that. And interesting enough, the only time when this data is publicly available is for 22 days or something before the permit is decided and a month afterwards. So anyhow, those are just some examples of some of the implications of what's happening in the construction industry that's going to change the legal processes, as well as many of the permitting processes and other things that are required. So thank you very much.